So we want to get rid of the ghost value. In order to do that, you have to remember that at this location ij, there are always two equations that are applicable. One is you have the Robin condition. The other one is the field PDE. As always here, we have this negative k partial square u partial square x plus partial square u and partial y square equals f of x. This field PDE is what we have done before. So we can combine this discrete form of the Robin condition and the discrete form of this field PDE so that we can remove the ghost value. Now let me rewrite these two equations. We have the PDE in its discrete form as, and the left hand side here has the conductivity term, and we have the right hand side as the load or source at ij. So this is the first equation. Then the Robin BC that we saw just now, in terms of the ghost value, I rewrite it as, so just substitute this ghost value into the field PDE here. So you're going to include this whole term inside the first equation. Let's give some values to all these coefficients and parameters just to see how the discrete equation look like. Yeah. So I'm going to rewrite the grid points again. Now if you are to write this, so now we have this final form of the boundary condition, which is where we put the coefficients into our matrix system. Now I want to note about the stencil at the boundary here. So for any point along the west wall, it has the same form except with the respective uij. So if you recall, the stencil looks like here. So it's connecting the 4 points, any 4 sets along the west wall. So when we construct the FDM code, we need a suitable data structure to place this stencil data in the correct location inside the matrix vector system. So that's it. Thank you.